what is the molarity of sodium ions in a solution prepared by diluting 40 milliliters of 0.7 molarity sodium sulfate to 100 milliliters? Let me write down the details on this. So molarity of Na plus is what we're being asked about. Dilute 40 milliliters of 0.7 molarity sodium sulfate to 100 milliliters. Good. Now, here's what I'm going to do. So I'm going to deal with a dilution problem first, and then I'm going to deal with the fact that I'm just looking at the sodium ion. For dilution problems, we will use the dilution formula. I know that I have 40 milliliters of or times 0.7 molarity sodium sulfate, and I'm diluting it to 100 milliliters. So larger volume for me always goes on the right, smaller volume always goes on the left. And because there's an of linked to the 40, or just by reading the problem and understanding it, I know my 0.7 has to be multiplied times my 40. And so my M2 squeaks in there. And one other thing I'll say about sig figs. So for the homework, again, so I've said this a couple times, 3 sig figs are always fine for anything except lab. And part of the reason I do that is because you can see 0.7. So I entered this in as 0.700, but the computer has taken the zeros away. So using sig figs for the online homework system doesn't always work how I would like. All answers to 3 sig figs except lab, in which we do them precisely and correctly. Anyway, so enough said about that. Let's solve for M2. For M2, I'm going to need 0.7 times 40 divided by 100, 0.28, 0 molar sodium to sulfate. Okay. Now we're not done yet because we've been asked about the molarity of sodium ions, and we have the molarity of sodium sulfate. This is not easy to do in a picket fence, but what I would suggest to you is the thought process is that if I, first off, this is a strong electrolyte. We talk about strong electrolytes a lot. Strong electrolytes break up 100% into ions. And we do this explicitly for strong acids when we think about pH. But if we take sodium sulfate and it's aqueous, and we allow it to break into its ions, we would see that for every sodium sulfate, we get 2 sodiums and 1 sulfate, and sulfate should be a -2 charge. And then, but here's the point of what I want to do. If we have 0.280 molar sodium sulfate, it breaks 100% into these ions. For every one of these, we create 1 sulfate, so the concentration of sulfate is 0.280 molar. And the concentration of sodium ion is twice as large because there are 2 of them. So double the concentration. 0.28 times 2 is 0.560 molar Na+. Oop, I lost you. Sorry about that. 0.560 molar Na+. So think of this as a regular dilution problem in which we then have to think about doubling the concentration because there are 2 sodiums for every sodium sulfate. I think there are some calculations you can do there, but I prefer to do this not on a picket fence. So let's go back and see. Any questions about any of the work I have shown? No? Okay. So let's share screen. 0.56, 0. Yep, spot on. And there is a range there. There's always a range for each of the answers.